In this video, we're going to be multiplying rational expressions. Remember, rational expressions are just something that looks like a fraction. So still my same rules for multiplying fractions are the same. When I multiply fractions, I multiply straight across the top, straight across the bottom. I do any canceling beforehand. So with our rational expressions, our steps are to factor and then cancel. Remember, you can only cancel tops with bottoms, and then to multiply. Again, you multiply across the top and across the bottom. So our first example is one that just has a whole bunch of monomials. So there's not really any factoring that I can do with monomials. Yes, you could write out where it says 6x squared, you could write out x times x in place of x squared, but as the numbers get larger, you're going to start wasting time writing out all of these x's and y's. So if you think back to 101, you had some exponent rules. Said that if you had exponents on top and bottom, that you could cancel them and you would actually subtract their index, or the actual exponent number. So I'm going to cancel this x squared with this x. Now I have two x's on top and one x on the bottom, so that means this x is going to cancel out with one of those, leaving me with one x on top. Also, in the case of the y's, I can cancel one y with one y. I could also have canceled y with this one down here, this y to the third. It would still give you the same thing, I would just cancel differently. So it doesn't matter where you cancel as long as it's a top with a bottom. So now I'm looking for anything else that can cancel. I see some numbers. 6 and 36, I could divide out a 6 and get 1 on top and 6 on the bottom. Also, with 5 and 25, I could divide out a 5 and get a 1 and a 5. So now I'm going to rewrite what I have left over, and then I'm actually going to multiply. So on the top left, I've got a 1 and an x left. On the bottom left, I just have a 5 times. On the top right, I have 1x to the 5th. And on the bottom right, I have 6y cubed. So now I'm looking for, is there anything maybe that I forgot to cancel? I could cancel that now, and then I would just rewrite the step. The x's on top can't cancel. I can't cancel anything with 1 and 6 or with the x and the y on top. So I am good to go ahead and multiply straight across the top. I've got 1 times 1 gives me 1, and x times x to the 5th. If you remember from 101, you add exponents. So I'll have 1 plus 5 gives me x to the 6th over, multiply across the bottom. 5 times 6 gives me 30, y to the 3rd. Now, just a little notation. I don't need to write the 1 in front of the x to the 6th. So my final answer would be x to the 6th over 30y to the 3rd. And that is as simplified as that one will go. So now for our next one, a little more complicated. I've got a whole bunch of trinomials. All the trinomials, if you remember, the first step is to factor. So any trinomial that I see, I need to factor. So top left, I'm going to factor that one. That, I'm going to go straight to my parentheses because it doesn't have an a. It doesn't have a number in front. So I'll have x and x. I need two numbers that will multiply to 9 and add to 6. Well, those two numbers will be 3 and 3. So I have x plus 3, x plus 3. If you want to write it as x plus 3 all squared, that's fine. Now on the bottom, I'm going to kind of do some trial and error. Now still, if you're going to do the long methods where AC slide or slide and divide, that will work. Remember, I just told you guys in chapter 7, we're going to try and start coming away from those more in-depth factoring and go more into guess and check. So if you think back, reverse foiling, the two numbers that go right here have to multiply to the first number. Well, that first number is 3x squared. So the only way I can multiply to 3x squared is 3x and x. Now I also have to multiply to the last number, which is 6. So my factors of 6 are 3 and 2 or 6 and 1. And I'm thinking ahead because I want them to add to 11x. So I'm going to put a 3 here and a 2 here, because then when I do the outer and inner of FOIL, I'm going to have 9x plus 2, which gives me the 11. Now, if you did either of your factoring methods, which you should be comfortable with, and you should be good at factoring by now, you will get the same way. I'm just trying to get us away from taking so long to factor and focus more time on doing the important things. Okay, so the last one that I will factor, I'm going to do the same thing, my guess and check. So I'll have 3x and x. Now this factor of 10, I've got 5 and 2 or 1 and 10. Those are the only ways that I can get to 10. Because it's negative, I need to be 1 positive, 1 negative. So I am thinking if I do 5 and 2, I can multiply that 5 times this 3. That'll get me to 15. And then if I have a negative 15 and a positive 2, that will get me to negative 13. So again, whichever factoring method you use, keep using it. I'm just trying to get us to take less time factoring. But if you pause the video, work out your factoring, you will get this same exact thing. It will just take a little bit longer. And then the last one, x plus 3. It's a binomial, it doesn't factor, so I can leave that right as it is. Alright, so now I've got everything nicely factored. Remember, step 1 is to factor. Step 2 is to cancel. I cannot cancel until I factor, unless, of course, everything is a monomial. So I've got an x plus 3 and an x plus 3. I've got another x plus 3 and x plus 3. I see a 3x plus 2 and a 3x plus 2, which looks like everything is canceled except for I've got 1 over 1 times x minus 5 over 1. So when I multiply across the top, I get x minus 5 over 1, which gives me just x minus 5. You do not need to write a 1 in the denominator, but do have to write a 1 in the numerator. So in this case, x minus 5 over 1, I could just rewrite it as x minus 5, and that would be my final answer.